Good morning. I'm Aanchal Vidyasagar from VNIT Nagpur, India. This is part of a study that I have done under the supervision of my guide, Dr. Rajashree Kotharkar. This is trying to assess the application of local climate zone framework, especially to study the heterogeneous urban environments. So, as we know that the urban landscape is transforming incessantly, and these rapid alterations will further complicate the already complex urban weave. And this urban landscape is in constant interaction with the surrounding or the immediate environment, due to which we have differential climatic conditions. Now, the narrative of the study is such that there have been various spatial classification systems ever since 1818. The Luke Howard, when he first started and understood the phenomena of urban heat island. So we mapped the historical development of these SCSs, and then we understand this widely accepted SCS known as a local climate zone and its growth in the past decade. And then we conclude with a need to modify the SCS, especially for the heterogeneous urban environment. So now the urban landscape, as we understand, it's essentially the form and the function. So the form is the structure and the fabric, in the sense the geographic setting, the geometry, the arrangement of the building and the streets, the surface materials, and the function, which is the one where we have the natural resources being depleted, and the anthropogenic activities which are contributing to the urban heat flux. Now, a spatial classification system. Now the researchers have been on this continuous quest to develop a rational and a systematic system or a framework to understand this very urban landscape, which is very very dynamic and complex in its own sense. So the need is that we need to evaluate these spatial temporal characteristics for the purpose of understanding or deciphering these varying climatic regimes and discern. And the way we do it is that we first discern or identify these diverse patterns, categorize them into various classes, and then essentially to capture the variations and quantify this complexity and diversity of the urban landscape. And SCSs have been used across various fields, not just in urban climatology. And as I just mentioned, that we can trace this SCSist because of the need of a standardized approach to analyze and compare urban areas. So as we see that in 1963, the first time urban climate map was launched as the first mapping mechanism for urban planning by Professor Nock. And on the right hand side, you can see the various parameters that an SCS hopes to capture. One is the first A is the micro meteorological parameters. B is a geographical one, and C is the urban landscape planning, which keeps on evolving and increasing, and wherein we have the land use, the land cover, the developed areas also is factored into various subtypes. So is the surface material and the anthropogenic aspect of it. And this map use this image essentially tells us that what are the shades and the grades that each SCS has been able to capture. And if we map the milestones, essentially from 1963 up to 1990, we relied on understanding the land use, or the spatial aspect of it. As we came down in 1991, in when Ellison was the first one who started off understanding or bifurcating the built into attached and detached built form. Then came Davenport, where he understood or he incorporated the surface roughness aspect into it. And then we started to come up with these iterations of urban thermal climatic zones, which factored much more than what was done earlier. And coincidentally, all of these spatial systems have been done by researchers based in the global north. So maybe one purview can be that the mental construct of perceiving things is quite homogeneous, and as compared to the global south, we are very, very heterogeneous. So that is one aspect to it. Another milestone was this was before the LCZ, wherein the role of green spaces was also incorporated via these two schemes. So overall, every all these SCSs of course are not foolproof. They have their limitations, and one of them is that they treat each class as a homogeneous urban cover, and they neglect the variation within each zone. So, if we speak about the growth of LCZ, I mean, enough has been spoken about it, and all of us are aware that it has been mapped across more than 1600 cities. Just briefly saying it, that it is, if we see the growth with respect to the application and the geographic spectrum it has done across climatic zones, scale, and economies, these are the various aspects that an LCZ studies. LCZ map, which was LCZ, which was essentially made to study urban temperature, has also been used across various other allied fields because it's a very uh, systematic way of understanding the way any uh, element like so is spread across a city. So it has stood the test of the time, and the strengths are, of course, as we just said, that it classifies into the standardized classes, which gives a consistent framework for analysis. It is comprehensive, hence it gives you a more detailed understanding of the urban environment, and this can be used in one of the way for the various mitigation strategies. And of course, it helps us to understand and compare these trends and patterns. But of course, it has its little limitations, especially when it comes to heterogeneous urban environments. One is that the probability of the internal homogeneity, which is done by each LCZ, is not there in heterogeneous areas. Second is that the combination of the classes and the subclasses that we need to use to be able to define these heterogeneous areas are not universally relevant. And the third aspect is that sometimes we've seen through our field measurements that each, like for example, the same LCZ3 might behave a little differently than the other LCZ3 in the same city. And this might be because of the impact of the adjacencies which are around those LCZs. So, in conclusion, I would like to say that the spatial heterogeneity, agencies, trees, etc., also have an impact on the urban microclimate, especially for heterogeneous areas. So, we need to develop an augmented SCS to be more, and which should be universally relevant also, maybe from the global south this time. And this will definitely improve the consistency and the veracity of how we report our climate. These are a few of the references which are part. So let's ideate, and thank you so much. I'm good on time.
Thank you very much for a survey of all the classifications, schemes that people have proposed, of which the latest, of course, is local climate zones. We have time for questions. This man here.
Thank you so much. Is that working? Thank you so much
I
for the
think
question.
yeah.
Thank you so much for the question.
Actually, for the recording, yeah. The party is there.
Yeah. Sorry. Thank you so much for the question. I've worked a little with green infrastructure types, and I'm trying to understand LCZ, so that was absolutely perfect. Thank you. I live in Sunshine Coast, Queensland. It's very much dominated in terms of heat island effect from adiabatic wind processes, and that's something that I don't understand how LCZs incorporate those wind-driven processes. Is this something that you are aware of?
I am not, because LCZs were essentially made to understand the difference in the urban temperature regime, and the wind definitely affects the way the temperature manifests across the city. But this will, I think, depend on the field measurements. So they will be able to, I think, let us know the exact the change, and that will help. And that's why I said this adjacency factor. What is surrounding one LCZ will matter a lot. That how the wind flows and how all of that also then changes the other related elements, because the thing is everything is interconnected. So I'm a landscape architect from the major part. So I always see things interlinked. So it's very difficult to just remove one aspect and see it in a silo. So I think once we start doing field measurements and tackling that with the and overlaying that on the LCZ map will give us a better understanding because it's very very dynamic. Yeah.
I think actually, if you talk to you now, because I do think that the next iteration will incorporate topography or its consideration.
Lay of the land.
With topography, yes.
May I ask a question?
Yes.
All local climate zones are heterogeneous. All of them are. It's just a question of the degree of heterogeneity.
Yeah.
Yes.
So, at what point do you think the heterogeneity within a local climate zone is too great
Yeah.
for it to be called a local climate zone?
Yeah.
But any city in the world, if it's an LCZ3,
Hmm.
they all look slightly different from each other. They just have broad characteristics in common. So,
Right.
at what point do you make the judgment this is no longer viable for what I'm doing?
Right side. So, as LC says that we should map at 250 by 250 meters, but there have been papers where they say you can go up to 100 meters. But the thing is, the more smaller the scale you do, the more grained it becomes. And then that is not something which the urban planners will understand because whatever we are doing as researchers, at the end of the day, if the urban planner cannot implement it, it's a futile exercise. So we cannot go very very small in scale. So if we have a certain scale of let's say 250 by 250, it's very difficult for me in India to do a 250 by 251 LCZ. So I have made subclasses like 3F, 37, 32, 5A, 6B to be able to uh, amalgamate what is actually happening and what is happening with this rapid urbanization, especially in unplanned and very very densely mixed countries like India. That this one LCZ3 might have a one tower of two, but then you cannot say that that one building is LCZ2. So that is the issue of scale and resolution that we are facing. And if we reduce the scale, it becomes very great. So that also we can't do. So that is the dilemma.
Okay, that makes sense. This man here.
Yeah. Thank you. I just want to point to your answer that you have to be careful to don't move to micro scale because on LCZ we are talking about local scale, so
True,
some
true.
level of generalization is necessary. So I would be very careful to go to the very fine scale.
Yeah, that. True.
Okay,
Thank you.
this lady here. And then I'm going to have to cover.
Thank you. It was a very interesting
Thank you.
presentation. So I do feel that there is some mixing up of the issue that I mean, my understanding is that you're trying to integrate some static system with a dynamic system. The immediate aim is to do the meteorology. That's what is going to give us the outcome. So
Right.
that's a very dynamic system.
Hmm.
And we understand this as an input to that system. So all your answers for application should come through measurements as you are planning,
Yeah.
which will give you the real meteorological answers, or through the modeling. So what the attempt of the LCZ is to really provide a framework to get you to a better understanding as well as better answers through modeling,
Through modeling.
to give you something for the application. So under this framework, if you like to add something or maybe if you reconsider your next level, that has you please you need to keep
Okay.
this.
Okay. Thank you.
Yeah.
Thank you, sir.
Thank you.
Thank
Yeah,
you.
very good. Thank you very much.
Thank you.